go back to our screen now. Can anyone tell me what a tangent is? So when I say tangents, what do I mean? Just write in the chat. You're also welcome to unmute yourself. What is a tangent? You can relate it back to your Euclidean geometry if you want. Wami, nice. Okay. So Wami said there's a straight line, that's really important, that touches a curve at a point. So at a single point, it touches the curve. Now, guys, this curve could be anything. Obviously, we're talking about circles right now, so that is our concern, and there's going to be a much better diagram in a second or two. But if this is our circle, if we have a straight line, it doesn't really matter where, it touches that circle. Obviously, this is us touching it twice, because you know, it only touches our curve once. Right now, there's a couple of important things that we'll need to chat about when it comes to circles, but this could be anything. It could be a parabola, and we could then talk about a tangent to the parabola. It could be a cubic graph, and we could then talk about a tangent to the cubic. There's many different tangent scenarios that we can work with. Like I said, what we're concerned with is the circle situation. So what is a tangent? A straight line that touches a curve once. Now, does anyone, actually, no, we're going to get to this now in a second. What you are going to have to incorporate now into the section is Euclidean geometry around the knowledge of tangent theorems, as well as your function knowledge around straight lines. And so there's some important things that we need to remember when it comes to this. So the first important thing that you need to remember when we are going to start working with tangents now is that if you think back to your Euclidean geometry, a tangent to a circle is perpendicular to the radius at your point of contact. So that's your tan perp rad reason from Euclidean geometry. And you can see this, oh, golly. You can see this in the diagram. Your tangent is AB, the orange line. Your radius is AC, the green line. At that point of contact, A, it forms a 90-degree angle. They are perpendicular to each other. Right, the next really important thing to know, I'll let you guys take a screenshot of all of this in a second, is the fact that two tangents, is anyone going to do anything? Yeah, apparently it is. Two tangents drawn from the same external point are equal in length. Now this is, if you go back to your Euclidean geometry, your tans from common point reason. This is obviously useful in knowing side lengths and allowing us to determine angles, because we know angles are equal sides. So what it's saying is that BT is equal to AB. There are tangents from a common point. From the point where they touch the circle to that common point, they are equal. Right, and then the last thing that's really useful for us to know is the equation of a straight line, which is what I said earlier. So a straight line is found using the general formula y equals mx plus c. And you've been learning this since grade 9, so it's not new. But it's going to be really important that we can now incorporate all three of these sort of useful little bits that we've learned throughout maths in these coming questions. So I'll just do that for you guys to take a screenshot, and then we'll have a look at our first example. Alrighty. So if we have a look at our first example here, we have been told to determine the equation of the tangent to the circle x minus 3 squared plus y minus 1 squared equals 25 at point S65. Okay, so we want the equation of this orange line that we have here. Now, anytime you're looking for the equation of a straight line, there's two important bits of information. You need to find the gradient and you need to find the y-intercept. Now, if you think of the gradient situation, remember that the radius from C to S, obviously if I could draw a nice straight line, is perpendicular to the tangent. So if you could work out what the gradient of your radius is, you can use that to work out the gradient of your tangent. And 9 times out of 10, this is exactly what you need to do. So the first thing I am going to do is work out the gradient of my radius. Okay, now we know the center's coordinates are at 3, 1. That's directly from my equation. And I know S's coordinates. So it's very easy. I just use my gradient formula and I substitute in. So remember, y2 minus y1 over x2 minus x1. If you use y1 minus y2 over x1 minus x2, fine. If you use a's and b's, fine. It doesn't matter. As long as you keep the 2's in line and the 1's in line, doesn't matter which order you put them in. Okay, so I'm going to say this is coordinate 2. This is coordinate 1. Again, if you'd swap them, it also doesn't matter. It makes no difference as long as you keep it in check. So y2 is 5 minus 1 over x2 is 6 minus 3. Now you can do this in your head or you just put it into your calculator. 5 minus 1 is 4, 6 minus 3 is 3. We get a gradient of 4 over 3. Now I'm going to move this one out. So the gradient of our radius is equal to 4 over 3. Like I said, we can now use this to work out the gradient of our tangent. So remember, we said earlier that your tangent is perpendicular to your radius. We'll write this properly with a reason now. That we now need to use this fact that I've just written down, which is not really cooperating with me. So we now need to use this fact in our next step. So who can tell me how or what formula we use when we're working with perpendicular lines? And you're welcome to unmute yourself or you can type it in chat, but what formula do we use when we are working with perpendicular lines? Anisile?
I was gonna say we're gonna use that rule that says the gradient of perpendicular lines multiplied gives us -1. And then we're gonna
Awesome.
Yes, ma'am.
Exactly. So guys, what's really important that you remember, and I think we spoke about it in last week's lessons, if you have the gradient of one line and you find the product of its gradient with another line, if you get -1, those lines are then perpendicular to each other. So what we now know, because we know that they have to be perpendicular to each other, so we know that this statement is going to be true. I know that 4 over 3 times whatever the gradient of the tangent is must equal 1 because the tangent is perpendicular to the radius. You do need to remember to give reasons. It's a geometric reason that we're using here, so we must give it. So we know that that statement is true because we know that they're going to be perpendicular. How you choose to do this now is completely up to you. I'm going to show you how to solve the equation, but I'll show you what the trick is now. So you are wanting to solve for the gradient of your tangent. So that means you need to get rid of the 4 over 3 being multiplied by it. So inverse operations tells me to just divide both sides by 4 over 3. So what you're actually just doing is saying -1 divided by 4 over 3. And so you get the gradient of your tangent to be -3 over 4. Now you don't have to show any of that working out. So this little step over here with the star, you don't actually need to show. If you just go straight to the gradient of your tangent with the reason, that's fine. Personally, that's how I do it because I remember the little trick. So the trick is, if you have a gradient, let's say of 4/3, the line perpendicular, you swap the fraction, so it becomes 3/4. And because that was positive 4/3, you now make it negative. If you had a gradient of 3/2, no, let's go negative 3/2. The line perpendicular, swap the fraction, 2/3. It was negative, it's now positive. So it's what we call the negative reciprocal. You don't have to remember these words. But basically, flip the fraction, change the sign. If it had been a gradient, let's say, for example, of -2, remember that's over 1. So your line perpendicular would now be positive 1/2. That's it. So you don't have to show this working out over here. Obviously, you're more than welcome to. There's nothing wrong with that. But if you just want to flip, change the sign, work with your negative reciprocal, that's absolutely fine. You're going to give your reason anyways. So what we have now established is that we have got y is equal to -3/4x plus c. So I still need to work out my c value, which represents my y-intercept. So how are we going to do that? What can I now do to work out c? And I'm just going to mute myself because I need to have a little cough, and I don't want to do that in your ears. Okay, so how am I going to find c now? I've got m, I just need to find c. Right, awesome, guys. So as Layla says, we go back to our formula, y equals mx plus c, and we now go and substitute in our point S. Oh, I mean, nice, I see you as well. So now we go and substitute in point S. Can one of you or any of you tell me why S specifically? Why am I not subbing in, say, for example, point C? So why must it be S? Good, Layla, exactly, guys. S is on the tangent, S is on the line. You can substitute in any point as long as it falls on the line you are working with. So if I'd given you a random point over here and I told you what its coordinates were, fine, substitute it in. But it has to be on the line. So S is on my line, I substitute it in. Remember, any coordinate is an x, y value. So 6 is x, 5 is y. So 5 is equal to -3/4 times 6 plus c. Right, -3/4 is a value. It would be 9/2. I'm going to back myself. You can correct me if I'm wrong. So this would be 5 equals -9/2 plus c. Yes, it is 9/2. And then inverse operations, 5 plus 9/2 equals c. So c is equal to 19/2, strange looking 19. Let's try that again. And so now we know y is equal to -3/4x plus 19/2. Now, guys, obviously you could write that 19/2 as a fraction, 6.5, if you wanted to. I don't know why I said 6.5, 9.5. I also said write it as a fraction. I meant as a decimal. Clearly my brain is just germs at the moment. You can write that as a decimal if you want, but honestly, why? Your calculator is automatically going to give it to you as a fraction. Just leave it as a fraction. You're not going to be marked wrong, so it really doesn't matter, but there's no need to write it in any other form. Okay, so the really important thing here, we wouldn't have been able to do any of this if we hadn't remembered our tan, perp, rad geometry rule. If we didn't remember that, then we wouldn't be able to do anything. We don't have enough information on the straight line to work it out. Right, so let's take a screenshot and then we'll have a look at the second example. Alrighty. So if we go to example 2 now, sorry, now there's something in my eye. We have been asked to determine the equation of the tangent to the circle x squared minus 6x plus y squared plus 2y equals 0 at the point 4, 2. Okay, now usually I would not tell you that it's a right angle. Usually I would expect you to say tan per rad, but obviously we're going to have to use that anyways in any case when we're working with the gradient. But before we even get there, what am I going to have to do in order to start doing anything to do with the equation of the straight line? So look at the information you've been given. What is my very first step that I now need to do? Because there's information that I need before I can even get to the gradient. Nice, Layla. So we need to find the center of our circle. We need to know what its coordinates are. Because if we go back up to the previous example we just did, our very first step was to work out the gradient of our radius. We can only do that if we know the center and the point of contact with the tangent. I know the point of contact, it's 4, 2. I don't know the center. I need to go and work that out. Now, I have to find the center based on the form of the equation that I was given. So what I mean by that is x squared minus 6x plus y squared plus 2y equals 0. What do I need to do to find the center of my circle? Nice, Kanisile. We have to complete the square. So we did this on, I don't even know what day we're on. Monday? I did this on Monday. So remember, you group your x terms. Obviously, if you want to skip the step and go straight to the completion of the square, that's fine. Group your y terms. Always put your constant on the right. In this case, it already was. Now we complete the square. So it's x minus half of negative 3. So x minus 3 squared. I said half of negative 3. I meant half of negative 6. Plus y plus half of 2, which is 1 squared, is equal to 0. But now I need to remember that I've added negative 3 squared and 1 squared on the left-hand side, sorry. So I need to add negative 3 squared on the right and 1 squared on the right. Now that I've done that, x minus 3 squared plus y minus plus 1 squared, sorry, is equal to 0 plus 9 plus 1, which is 10. Okay, so now we have got both center and radius of my circle. I don't really care about the length of my radius. In this context, it's not important for me, but I do want to know what my center is. So the center of my circle is at positive 3, negative 1. Remember, the signs swap. So this is at 3, negative 1. And now I can go and work out what the gradient of my radius is. So gradient of radius is equal to, you do not need to write the formula. So here in the first example, I wrote down the formula. You're given it on your formula sheet. Don't rewrite it. Just go straight into the substitution. So if this is 0.2, this is 0.1, 2 minus negative 1 over 4 minus 3. 2 minus negative 1 is 2 plus 1, so 3 over 1, which is just 3. Don't really need to do much there. Now again, I wouldn't show all that product calculation thing for your tangent. I would now just say, therefore, the gradient of my tangent is equal to, now this is where I personally use the trick. Otherwise, just quickly do the product on your calculator. My gradient for my radius was 3, so that's 3 over 1. The trick, flip your fraction and put in the opposite sign. Positive 3, so negative 1 over 3. So my gradient of my tangent, negative 1 over 3, and I give my reason tan per rad. Again, there we go. And now that I have my gradient, I know that y is equal to negative 3x plus c. As you guys already said, from this point, I now substitute in a point that's on my line. So I'm going to substitute in for 2. 2 is equal to negative 1 over 3, sorry, times 4 plus c. So therefore 2 plus 1 over 3 times 4 is equal to c. And so c is equal to 10 over 3. Y is equal to negative a third x plus 10 over 3. Fortunately, like I said, a lot of the time you're going to get a gross answer. It's not the end of the world. It is what it is. Alrighty. There is a question that said, if we were asked to find the radius, what would we do? So do you mean the equation of the radius, or do you mean the length of the radius? Honestly, was your question? Length, okay. Once you've completed the square, remember that this value here is r squared. So you would just square root it, and that would give you the length of your radius. Alternatively, if you really wanted to be fancy, because you know the center and because you know the 0.42, you could actually use your distance formula and you could go and work out the length. But I wouldn't waste my time. I would just square root whatever r squared was. But you can if you want. If you really enjoy the distance formula, go for it. Awesome. Okay, guys, let's take a screenshot. And then as you can see, you're going to try one by yourselves. 2 by yourselves. Okay. All right, so this is what you're trying. Determine the equation of the tangent to the circle that is in nice center radius form at the point -2, -3. And determine the equation of the tangent to the circle x squared minus 2x plus y squared plus 4y minus 5 equals 0 at the point -2, -1. Cool. I'm going to give you 5 minutes. I'll check in after 5 minutes and see where you guys are at. If you need another minute or two, that's fine. But let's give these a try. Go back to your screenshots if you're not feeling sure, or just ask. You can unmute yourself, you can put in the chat, you can send me a message, whatever you And then guys, just quickly, please don't forget to do your quizzes. You've got a quiz tonight, you have a quiz from last week. All the quizzes are actually still open. I know that some of you were struggling to access last week's quiz. I have fixed that. I have no idea why it keeps fighting with me. Clearly, I'm just not well liked. So please make sure you do the quizzes. It's really important for you to be able to see whether or not you're actually improving. It's important for you to get the practice. It's important for your parents or your guardians to see what's happening. So please do the quizzes. I'm not saying go straight away and take up like an hour of your time. But even if it's tomorrow on the weekend, you're not even going to need an hour. Spend some time doing the quizzes. You have exams coming up. Use those as a form of revision, as a form of practice. Okay, really, really important that you are doing them. Okay, guys, we need a bit more time. Thumbs up if you're done. Thumbs down if you need another minute or two, please, just that I know. Okay, cool. We still need another minute or two, so I'll give you that. If you're done, that's cool. Double check your answers. The next one's going to be fun, so you can get ready for that. Okay, looks like some of our thumbs down have changed to thumbs up, which is awesome. If you're not done, don't stress, just take a screenshot. You can check yourself. So let's have a look. So A, you know exactly where your center is, which means that you can go and work out the gradient of your radius. And so the gradient of your radius here was -2. I didn't put any reasons. Oh my gosh. Absolutely ridiculous. So this would have to be tan per rad. Same on the other side. Oh, what I was thinking here. Okay, fix that reason in a second. Once you have your gradient, you substitute in the point you know is on the line and you get your equation. Right, I'm gonna, sorry, scroll again, it just didn't want to work there. So just remember your reasons, please, please, please. This is my own fault, I should have remembered my reasons. Okay, the only thing now in question B is you did have to complete the square in order to find your center. But once you had that, easy peasy, no stress.
Ma'am,
Yeah.
ma'am, can I ask why is the two negative? Why is it -2 in question
Wait,
B?
no, you're very much right. Okay, so let's fix my nonsense. It shouldn't even be -2, it should be +1, hey? So center is at 1, -1. No, guys. Really, my brain is just a little fraught. Okay. So there we go. It should be +1, so this should be -1. So when we want the center, let's just fix that. It would be -1 minus -1. And so just tell me if you disagree with anything I'm doing right now, okay? -1 minus -2, but the numerator is 0, so that would be 0. This is a horrible question that I've asked you, and I've just erased everything. Okay, Owami, talk to me while I'm trying to figure out why technology hates me.
Okay, ma'am, I wasn't in the lesson on Monday, so can you please explain where? So you've written the first one where the second bracket is y plus 2, and then in the second line after that, y is 1. So why did that change from 2 to 1?
Yeah, I don't know. Yeah, no, because I'm losing my mind. Let's just make sure I haven't lost my mind. Okay, so if we group this, that's right. So it should be +2. So yes, it should be +2. Okay, so my center is at 1, -2, which means my gradient is -2 minus -1 over 1 minus -2. So that becomes -1 + 1, which is -1 over 3, which means the gradient of my tangent is +3. So, oh! Okay. So over here, that now means I've got y is equal to 3x plus c. Let's want to work for us. C. Clearly I was tired and this was all happening, and I substituted my coordinates. Some very bad words are about to come out of my mouth. This doesn't work hard. This is not hard that I'm asking it to do. Okay, so -1, 3 times -2 plus c. There's 6 plus 6, so this would be 5 equals c. So do we all agree with the equation 3x plus 5? Does that look better? Grand. Okay, thank you, Ami. Yes, shows you what a really stupid mistake does, hey? Messes up your whole thing. Right, that's on me. I do apologize. I can't even remember when I did this, so lesson to self. Double check, triple check. Okay, so let's take a screenshot of the correct answer now. Oh, these things happen, guys. Thank you for picking it up. You guys are on it. Appreciate you. Okay. So let's have a look at this next one. This is a nice, exciting one. So it says in the diagram below, M at -2, 1 is the center of the circle. So we don't have the equation of the circle, we just know where the center is. The line y equals 1/2 x plus 7 is a tangent to the circle at P. Calculate the coordinates of P. Okay. We don't have the equation of the circle. We don't know anything about the length of the radius. We don't know anything about P. That's what we're trying to figure out. All we have is the center of my circle, as well as the straight lines equation. Right, so to help us out a little bit here, if I drew in the line MP, what is special about the line MP and the tangent at point P? What is happening between those two lines at point P? So basically, what is point P to those two lines? Okay, cool. It's definitely intersecting at 90 degrees because we know tan per Brad. What else do we know? We will use that as well. What else do we know about that point P? So between those two lines, what is special about point P? Go back to your functions knowledge. Let's say, for example, I gave you something like this, and I asked you what is special about points D and E. What would you tell me those points are? Okay, grade 12, when you have two functions that cross or intersect with each other, what do we call the point where they intersect? What do we call the point where two functions intersect? Nice, Kanisile. I'm worried I'm going to sneeze, so if I suddenly mute, just roll with it. Okay, guys, where these 2 points meet, or where the 2 lines meet rather, that point is where those 2 graphs are equal to each other. It's a point of intersection. So what that means is if we can figure out the equation of MP, because we know the equation of the tangent, if you make them equal to each other, you can figure out the point where they intersect. So now instead of working out the equation of the tangent, we want to work out the equation of the radius so that we can make them equal to each other to go and work out our point of intersection. Okay, so we're going backwards. What we know is the equation of our tangent. So we know that our tangent equation is a half x plus 7. What is the gradient of your tangent then, guys? According to the formula, what is the gradient of your tangent? Well, I mean, nice, a half. Okay, so based on what we've spoken about, what is the gradient of your radius then? You know the gradient of your tangent, what's that of your radius? Nice, guys, well done. Okay, so our gradient of our radius is -2, and you just put your reason tan per Brad there. All right, so what we now know is half of our equation for our radius. Just want to move this up so we've got space. We know that y of our radius is equal to -2x plus c. Okay, now remember, to find c, we need to substitute in a point that we know is on our line. What point is on our radius that we know? Nice, Awami. M, the center of your circle. So we're going to substitute in the coordinates for m, which is -2, 1. So 1 is equal to -2 times -2 plus c, which means we've got 1 minus 4 is equal to c. So c is equal to -3. So the equation of our radius is equal to -2x minus 3. And now you've got your 2 equations. I'm going to run out of space here. You know that this is y is equal to -2x minus 3. You know the tangent equation is y is equal to a half x plus 7. And so to get your point of intersection, I'm not going to write the whole thing, your point of intersection, you now just make them equal to each other. So a half, a half x plus 7 is equal to -2x minus 3. It's a point of intersection. You equate your 2 equations and you go and solve for x and y. Okay, so group your like terms. We've got a half x plus 2x is equal to -3 minus 7. A half x plus 2x gives me 5 over 2x is equal to -10. Times both sides by 2, 5x is equal to -20, divide by 5, x is equal to -4. How will you now go and find the y coordinate? You know the x, how do you find the y coordinate now? Nice, we sub that x value into one of our equations. It doesn't matter which one. So either the half x plus 7 or the -2x minus 3, it's completely up to you. My advice would be sub it into the one that you were given the equation for, because then you're not potentially working with an incorrect answer, but honestly, it makes no difference. So if I substitute it into the one I know, y is equal to a half times -4 plus 7. A half times -4 is -2. And so y is equal to +5. And so what that means is that my coordinates for P are at -4, 5. So always just remember that a tangent and a circle have a point of intersection. That point of contact is their point of intersection. And a point of intersection is where your formulas or equations are equal to each other. And we're going to use this a little bit later on next week when we start talking about the relationship between lines and circles that aren't necessarily tangents. Alrighty. So let's take a screenshot of this. And then you're going to try one by yourselves. Okay. Right, I'm going to make this a touch smaller, just a touch. Okay, so I've got a diagram for you here that's basically the same thing. Y is the line y plus 2x equals 11 is a tangent to the circle centered at P1, -1 at the point QXY. I want the equation of the the equation of the radius PQ. So what is the equation of that straight line PQ? And I want the equation of the circle through Q with center P. So what basically the equation of the circle. Right, the only hint I'm going to give you is just remember, whenever you are given a straight line, where the equation is not in standard form, put it into standard form, which is y is equal to mx plus c. Because that's the only way you can figure out what your gradient and y-intercept is. Okay, I'll give you 5 minutes again, and then we'll have a look. Okay, I'm going to give you 1 more minute and then we're going to have a look. Okay, guys, let's have a look. Right, so determine the equation of the radius. So we know, firstly, we need to put this into standard form. So y is equal to minus 2x plus 11. To know the gradient of your tangent is negative 2, which means the gradient of your radius is a half. Again, I'm apparently just not enjoying reasons. Tan, rad, whatever. And so y is equal to half x plus c. You know that point P is on your radius, so you can substitute that in and you get y is equal to a half x minus 1.5 or 3/2. Okay, then it says determine the equation of the circle. So you know what the center is. That's easy to go and substitute in. You can get that automatically, but you need to find r squared. And in order for you to do that, you need to know a point on your circle. You know the center, but that's not on your circle. You need to go and work out what Q is. So you need to go and work out that point of intersection and work out what Q is so that you can substitute it in and find what r squared is for your circle. Okay, so this was a slightly trickier one that we had here, but if you read your questions carefully and you remember that your point of intersection lies on both the circle and the tangent, you can use that information in both cases with the straight line or with your circle. All right, so I'll leave this here, take a screenshot,